We can create 4D simulations of construction operations and work plans using our Revit model in combination with Navisworks Manage. The steps involved include exporting our Revit model in a format that Navisworks can import, creating a schedule of the tasks that will be required in the construction process. In this case, I'm using a simple list of tasks with expected start and expected end dates that was constructed in a spreadsheet program. Navisworks can import task data from many types of scheduling programs, as well as from simple comma-separated value text files. Then we pull those two pieces together, integrating our building model with the task timeline in the Navisworks Manage application. The key to creating a 4D simulation of the construction process is linking the elements in the building model with these tasks, and we can do that by attaching individual elements or sets of elements to each of the tasks in the timeline. Creating these sets can be challenging, but it's really the key to working effectively within Navisworks Manage. Let's take a look at some of the ways that those sets can be created. We'll close the timeliner window temporarily to give ourselves more room to view the model. We can explore the building model by selecting items in the selection tree. We can choose the entire model, a specific level of the model, all the elements that are contained in that level. We can expand the hierarchical list to see the elements on a level, then choose individual items or many items by shift-clicking. Now, if you can't see an item, it's typically because it's contained within other parts of the model. To see it, you can say Hide Unselected, and then you'll focus on the elements that are selected. Unhide All returns your view of the overall model. We can create a set containing all of these structural columns at level 1 and save it so that we can associate that set with a construction task. To do so, we can select them all by shift-clicking. Then open the Sets pane if it's not already open. In the Sets pane, we can right-click and say Add the current selection, which will create a selection set, and we can give that a name. Now, navigating through an entire model and creating selection sets this way by selecting individual elements can be a very cumbersome process, so there are better ways to do it. For example, a very powerful way of creating selection sets is to find items and then choose them based on their parameters. We can define a search that will look within this set of model elements and then look for specific criteria. For the element category, we can look for things that have an element name which contains, and choose one of the available values. Let's go for those 10 by 49s. When we say Find All, they're selected, and we can save this search by returning to the Sets pane, saying Add Current Search, and giving that a name. Notice the difference in the selection sets, these being selected manually and these being searched with a little binocular icon indicating that this is a search set. The advantage of using search sets is that they'll dynamically update. As new elements are added to the model, the search set will find the new elements that also meet that criteria and include it in the set, whereas the manually selected set won't. Let's open the Timeliner tool again and look at how we attach a set to a task. I'll close the Find Items pane to give ourselves some more space and expand the Timeliner pane. If we scroll to the top of the list and find that Level 1 Columns task, we can move over to the Attached Columns and say Attach a set to it, then choose the First Floor Column Search. And all of the elements associated with that search set are now linked to that construction task. Well, working with search sets greatly improves our ability to pull together the different building elements that are needed for each of the tasks. Creating those search sets based on element properties like the element name or type is still pretty cumbersome. So let's look at another very powerful strategy for working with the parametric capabilities of Revit and those search sets to make it much easier to link building elements to specific construction tasks. Let's return to Revit and look at how we can add a parameter to handle that linking. To create a new parameter that we can use to link our building elements to construction tasks, let's start by creating a shared parameter. Switch to the Manage tab, open the Shared Parameters dialog, and let's create a new parameter group. We'll call this group 4D Simulation. Within that group, let's create a parameter. We'll call it 4D Task ID, and it'll be of type text. Say OK, and OK to finish adding that as a shared parameter. Now the reason for adding it as a shared parameter is now we can use that same parameter consistently in many different project files and appear in schedules and tags. Having created the shared parameter, now let's create a project parameter and associate it with each of the different building elements. We'll choose Project Parameters, add one, and we'll choose from amongst the shared parameters that we've already defined. We'll choose that 4D Task ID. Let's group it so that it appears in the Properties palette under the Construction grouping. Then we can choose the elements that we want to associate it with. We can select all, but it really isn't appropriate to associate that with everything. For example, the areas, the views. We should uncheck any of the categories where a construction task wouldn't apply. Say OK. Say OK to close the Project Parameters dialog. And now when we choose a building element and look in the Properties palette, you'll see that the 4D Task ID parameter is available for us to enter values. Having created this parameter, our next step is to select all the building elements that will be associated with tasks and fill in that value. To do so, we can return to the Task Timeline document, review the task IDs that are associated with each of the different elements. For example, for the level 1 columns, we're using task ID 120, for beams it's 130, and for joists it's 140. And then return to Revit to enter those values. Think carefully about the views that you should use to make it easier to select each of the different types of building elements. For example, to get the beams and the columns as well as the joists, I might switch over to the Ceiling Plan view, where I can select all of the elements and then filter. Let me check none, then choose those columns, say OK, and now just those column elements are selected. I can confirm the number of selected items by hovering over the pull-down menu in the Properties palette, then choose the 4D Task ID field and enter the value of the task that you'd like to associate these elements with. Using similar steps, we can select all of the beam elements by doing a drag select, then filtering. We'll choose just the framing girders. All of these will be associated with the task ID 130 in our schedule. And again, doing a drag select, then filtering to select all the joists. These elements will all be associated with task ID 140. By repeating these steps, you can associate task IDs with each of the different building elements that you want to include within your construction simulation. When you've completed entering those values, you're ready to export your building model to Navisworks. To do so, let's switch over to a 3D view. For exporting, you'll want to use a 3D view that shows all of the building elements because only the elements in the view that you choose will be exported to Navisworks. To help remind yourself, you might want to create a special view with a name like Link to Navisworks that you'll always use for exporting the building model. To export the building model, switch to the Add-ins tab, click in the Drawing area, and then choose the External Tools menu and pull down to select the Navisworks File Exporter. Give your export file a convenient name, click Save, and watch as the building elements are exported to the NWC file format. Having exported the elements of the building model, we're now ready to bring the model and the task timeline together in Navisworks. Let's start with a new Navisworks model. The first step is to import our model of the building elements by appending it to this Navisworks file. We'll choose Append, choose the NWC file format, and we'll find the building model that we've just exported from Revit. Say OK, and you'll see it appears within the model area, and we can select the elements in that model. The next step is to import our task timeline, and to do that, we'll switch over to the Timeliner pane. There are currently no tasks defined for this Timeliner project. To import the timeline that we've already created, I'll switch to Data Sources, then click the Add button to bring in the CSV file that we've been working with. You'll see that many other project scheduling formats are also available, but we'll choose the CSV. Choosing our CSV file, the Field Selector dialog opens so that we can map the field names in our CSV file to the column names within the Navisworks Timeliner tool. For example, the task name in Timeliner will map to our title field, the external ID will map to task ID, the planned start date will map to our expected start column, and the planned end date will map to our expected end. One critical one we want to be sure to include is user 1, mapping that to the task ID. That will be the field that we use to map the 4D task IDs that we've entered in Revit to the task IDs in the project schedule. Say OK to accept these. Then go to the Refresh menu and choose All Data Sources to rebuild the entire task hierarchy. We want to create a new hierarchy out of the tasks in that CSV file. Say OK. And when we return to tasks, you'll see that the list of tasks from the CSV file now appears. Having created these tasks, our next step is to create a series of search sets that will let us map the building elements using the 4D task IDs that we entered in Revit to each of these tasks. To create the new search sets, we click the Find Items button, then enter criteria that we want to match. In our case, we'll go to the element, 4D task ID, and say that, for example, we want to do one that equals the value of 110. We can click Find All to see which elements in the model are matched. You'll see actually the floor slab at the first level is matched. We can come over to the Sets window, say Add the current search, and we'll actually call that 110. To make the mapping automatic, we want to have a one-for-one match between the names of the sets and the task IDs that we'll be matching them against. Hit Enter, and let's go through and create a second one. We'll choose the 120 elements. Hit the Enter. We can add the 120 to our search sets. We'll use 130 and add it to our search sets. 140. And continue using the same procedure to create search sets for each of the different task IDs that we want to match against. When we're done entering all of the different values, we can close the Find Items window and return to the Task Timeliner pane. Then choose the Rules button on the Tasks tab. Then choose the Rules button on the Tasks tab. The Timeliner Rules window lets us create and edit rules that will map Timeliner tasks to specific items, selection sets, or layers within the model. Let's choose the middle option, Selection Sets, and edit the rule. What we'll be choosing is to map the User 1 column, that's the one that contains our 4D task ID, to selection sets with the same name. We'll say OK to that rule. Say Apply those rules. And when we close this window, we can scroll over to the attached column and see that each of the different tasks in our timeline now have a search set associated with them that will automatically pull elements from the building model. Now that we've attached our model elements to specific tasks in Timeliner, we're ready to perform the simulation. Let's close the Sets window just to create more space on the screen. I'll even hide the Gantt chart since we don't need to be looking at that right now. Let's set up the simulation by looking at the options available under the Simulate tab. We'll start with the settings that are available for customizing the simulation. One important setting to check is the interval size. That will determine which increments are displayed as we step through the simulation. Currently, it's set to use 5% as the interval size, so 20 different steps will be shown. If that's not what we have in mind, for example, if instead we'd prefer to show a simulation of daily activities, we can change that to display days and then reset the interval size to show every 1 or 2 days, whatever we prefer. We can also adjust the duration of our simulation. Since for this example we want to look at the sequence of construction operations in some detail, let's change that to a much longer duration, say 60 seconds. Let's say OK, and we're ready to run our simulation. To do that, let's click the play button. Then sit back and watch as Navisworks steps through every day on the project schedule, looks at the activities that are scheduled for that day, and in turn brings in the different building elements that are associated with those activities, creating a 4D simulation. You'll see that at each layer, the floor deck appears first, followed by the columns, then the beams. When the beams are complete, the joist systems are laid across the beams, and then we're ready for the next floor deck. You'll also see that the exterior walls show up as the next floor level is being built. And at the end of week 26, our simulation of the building project is complete. After the 4D simulation has been completed, we can step through it a day at a time to take a closer look at the construction activities. We can click the Step Forward button and move forward one day at a time, watching the joists appear, the joist being completed, and right there we have a bit of a problem. What's happening is the exterior walls are coming in as one large component. The core of the walls, the interior surface of the wall, and the exterior surface of the wall are currently one building model element. So when they appear in the model, all those layers appear at the same time. Now this isn't strictly accurate. Typically we'd build the core of the wall first, and then later add the exterior surface, and finally after the building's weathertight, we'd add the interior surface. So to improve the accuracy of our construction simulations, we can take these multi-layer building elements and break them down into their individual parts so that we can place the parts independently. To do that, let's return to Revit and create parts for some of those elements. In Revit, it's very easy to decompose building elements into parts. We can select individual elements and then go to the Create Parts tool to break down that element into the component parts. We can do that one element at a time, or it may be more efficient to switch to a different view. We can drag to select all of the elements, then filter to select only the walls. But this method is still selecting both the exterior and the interior walls. Sometimes it's better to actually choose one of the wall elements that has the type that you want to decompose, and instead use the Select All Instances tool. In this case, we'll select all the instances visible in this view, and that'll get just those exterior elements. We can then use the Create Parts tool again to break those elements down into the parts. With these new parts and plates, we'll also need to adjust our task timeline to take advantage of the parts. So let's switch over to the timeline. And you can see that we've subdivided the exterior walls tasks at each of the different levels into 3 different tasks, 150, 151, and 152. Similarly, at the second level, it's 250, 251, and 252. Let's return to Revit now and map these new task IDs to the parts. Let's zoom in so we can take a closer look at the parts on our walls and assign IDs to them. We'll use the zoom tool. Let's take a look at this corner. To make it easier to select the parts and assign IDs, create a special view, and for the parts visibility parameter, set it to Show Parts as opposed to Original or both. Then we can select the individual parts and work with them. Each of these different parts has the 4D Task ID parameter available, and we can assign the task IDs that match our new timeline schedule to each of the parts. For example, our core layer is now task 150. The exterior face is 151, and the interior face is now task 152. Assigning the 4D task ID to each of the parts individually would be a very time-consuming task. So another strategy you can use is to create filters which will help you select all the parts which use the same material type, then hide all of the other part elements in a view and select the remaining parts to assign a single ID to all of them. In the visibility graphics overrides for this view, I've set up filters. And each of those filters is designed to select parts based on their material properties. To select the parts that make up the core of the exterior walls, we can turn off the exterior surfaces on the inside, the outside, as well as the airspace, which is also part of the wall. When we say OK, you'll see that the parts that do not meet this filtering criteria disappear from the view. We can zoom out now, use a drag select, then filter for parts to choose all of those parts that make up those core layers of the wall. With these selected, we can now enter the 4D task ID. We'll use 150 because that's the task ID associated with those core layers. Apply it. Then we can return to the view, choose the visibility graphics again, and use a different set of filters to select the other parts. For example, the outer layers, choosing the EIFS parts. We can repeat these steps to select the parts and associate their task IDs at each of the different floor levels. With the parts created and the task IDs assigned at each of the floor levels, we're now ready to export our model to Navisworks again. Let's switch to that Export to Navisworks view so we're sure to get the 3D model that shows all of the different elements. We can return to the Add-ins tab and choose the External Tools, the Navisworks File Exporter. This time I'll want to check one very specific setting though. Because we're working with parts, I'll want to check that the Navisworks settings are set up to export that part information. The important thing to check is that this Convert Construction Parts checkbox is enabled. If it is, then the parts information will also be exported to Navisworks for scheduling. Let's say OK. Give this a new name to reflect our updates. And once again wait as the building elements are exported to the Navisworks NWC file format. Returning to Navisworks, we can append that new NWC file to import our improved version of the building model. Say OK. Let's eliminate the prior one so we only have the new one in this project file. If we expand under the project selection tree, you'll see that for the EIFS wall elements, parts are also listed, the individual pieces that make up the different layers of the wall. We'll also need to update our task timeline with a new schedule that takes advantage of these parts. To do that, let's go to the Timeliner pane. We'll choose the old task timeline and delete these tasks, as well as switching over to the data sources and deleting that old data source. Instead, we'll add a new CSV file containing our new task timeline that takes advantage of the parts. Say OK. Once again, we have the option of mapping fields to different column names in Task Timeliner. We'll say OK to select all those same settings. And then we'll need to refresh the timeline by choosing all data sources and to rebuild the task hierarchy. Click OK. When we return to the tasks, you'll see that our new tasks, including the 3 different tasks related to the exterior walls, all appear in the timeline. If you scroll to the right, though, you'll see that our attachment rules need to be recreated. To do that, we'll choose the Rules button. We'll apply those rules, then close this window, and when we scroll to the right, you'll see that attachments have been made between the different search sets that we've defined and each of those different task activities. Remember, you will need to create new search sets for each of the new task IDs in order to have the linking between the building elements and the tasks happen automatically. With our new version of the building model, the new task timeline, and our new search sets in place, we're ready to run an updated simulation. To do that, let's close up the Sets window so we have a little more room on the screen. We'll return to the Simulate tab and review those settings to make sure that everything's still to our liking. That all looks good. We'll say OK. And we're ready to click the play button to run the new simulation. Again, Navisworks will step through the project one day at a time, looking at each of the different tasks that are involved on that day and the building elements that are associated with those tasks. When the simulation is complete, we can stop the simulation and play it again, this time stepping through to focus on the days surrounding the activities that we've changed. We'll add in the joists, add in the deck, and on day 93 you can see that the EIFS walls are appearing first as the core layer, and then a few days later the exterior showing up. By using parts in our building model and then scheduling each of the different layers that make up our wall individually, we're able to create a more accurate simulation of the construction operation.